So now we're going to be working with combining like terms. So what is a term exactly? Well, a term can be a number, a variable, or the product of a number and a variable. So just to give you a few examples, a term could be something like 2. 2 is a term. You could have x, any variable. You could have a product of numbers and variables. So you could have maybe 1/3 x or 2y squared. You could also have two variables as a product. Something like ab would be a term. Anything maybe like 3ab is a term. So there you go. In an expression, terms will be separated by a plus sign or a minus sign. So terms will be either added together or subtracted. A coefficient, another definition you need, is a number that is multiplied by a variable in an algebraic expression. So in the term 7x, 7 is the coefficient. In 8y squared, 8 is the coefficient. In 3/10 BC, 3/10 is the coefficient. And in 2/3 p, 2/3 is the coefficient. Something that's very important, and something that I think that you probably already know, but just may need it in your notes. A variable without a coefficient has a coefficient of 1. So if you're being given x, well, that has the same value as 1x. If it's just 1x, it's 1x. So if you had n, that is equivalent to 1n. Like terms are terms that have the same variable raised to the same power. Both things must be true. So here are some example sets of like terms. If I have x, 2x, 33/100ths x, 1/4 x, they all have x. And x is technically raised to the first power here, but we don't see that. But they're all the same variable raised to the same power. The coefficients are different, but the coefficients aren't part of the definition for like terms. You need the same variable raised to the same power. Here's another example. 5pq squared, 1/3 pq squared, and pq squared, they're all like terms because they all have the same variable or variables raised to the same power. Pq squared is what defines that like term. 1pq squared is a like term with 1/3 pq squared, or 5pq squareds. You could combine them if you needed to. And just like all of these have the same variable raised to the same power, if you have constants or just like numbers that don't have a variable, well then they all technically have the same variable because they don't have one. So 7/300, 1/8, square root of 16, which is 4. They're all like terms because they have the same variable because they don't have one. Here are some non-examples of like terms, just in case you might get confused here. 11y is not like terms with x squared because 2 reasons. They don't have the same variable, and x is squared here. Y is not squared, so 2 things. 15 doesn't have a variable, so they're not like terms. xy, you may think that this is the same term and this is the like term, but xy defines the term here. So when you have a variable times a variable, that's a different unit size from y or x squared. So these are altogether not like terms. So if you were asked to simply identify like terms, let's look at example A. We have 3b, 1/3 x squared, b divided by 2, 6x squared, and 19. Just want to take a step back and find things that are the same or different as far as like terms are concerned. Do I have any b terms other than 3b? I can kind of scan and see, oh yes, this is b divided by 2. Well, b divided by 2 is actually equivalent to 1/2 b. If you're confused, we can talk about that later. But this is a like term with this because they have the same variable raised to the same power. I just put a box around each of them to denote that they are like terms. How about 1/3? Is there anything that, there's no variable to no power. Is there any other term here that doesn't have a variable? Well, 19. So I can go ahead and maybe circle those. If you don't have the different colors, it's okay. You can just make different shapes around them. That's what I like to do. Maybe underline them differently. Whatever works for you. And then I have x squared left and 6x squared. Well, they're both x's squared, raised to the second power. So they are like terms because they are the same variable, have the same variable raised to the same power. So I actually have 3 pairs of like terms here. And I'm just identifying them for now. So I'm done. In example B, I have this wide list of terms. 5a, 3y squared, 7t, 4.5y squared, or 4 5/10, 4z, and 2/3 a. So I like to start at the beginning and scan to see what I have, if I have any like terms, or if not. 5a, a has no power, so I'm looking for any a terms. Lo and behold, 2/3 a, they are like terms, so I'm just going to go ahead and say, well, 5a and 2/3 a are like terms. I'll move on to my next term. 3y squared, I'm looking for any y squareds, and here is one, 4.5y squared, so I'll box those in. What I have left is 7t and 4z. While you may be tempted because you don't like to have things left over, they don't have the same variable. For all you know, t and z represent different numbers. They're not the same unit size. You cannot combine them. They are not like terms. So we just leave them alone. Example C. I have 12x, 12x squared, and xy squared. I'm going to go through and see if I have any like terms. 12 does not have a variable. Are there any other terms without variables? There are not. So 12 is going to kind of be on its own. How about 12x? Looking for any x terms, just x. Well, I have x squared. Well, x squared is not the same unit size as x. They are not like terms. And then I have xy squared, but they're not the same. They're not like terms either. 12x squared, is that the same as an xy squared term? Definitely not. So do I have any like terms here? I don't. Is that okay? Absolutely. Just be confident in yourself. So when we come to combining terms, you can only combine like terms. Let's take this for example. I have 4 x's here. 4x. I have 5 x's here. So 4 x's plus 5 x's is 9 x's. That's this whole concept of adding the same unit size. So 4x plus 5x is equal to 9x. What did I do to get from 4x plus 5x to 9x? Well, to combine like terms, you add or subtract the coefficients, in this case 4 and 5, based on the sign in front of each particular term. So this is telling me to add them. If it's plus 5x, I know to add them. You're going to notice as we get into some longer algebraic expressions, you may need to use the commutative property of addition to get like terms near each other if you're more comfortable that way, and that's absolutely okay. Just be careful to make sure you do it correctly. So here are some brief examples. If I have, in my first example, 7x plus 2x, well, that's just like our previous example, only now I don't have a picture to map it out. Does that mean you can't draw one? No, you can if you understand that you're adding the same unit size. 7x's plus 2x's, well, I have 7x plus 2x. I add the coefficients, 7 and 2, and I know that that is 9x. Okay. How about B? I have 5x to the third power plus 3y plus 7x to the third power minus 2y minus 4x squared. We've kind of upped the ante really quickly here, haven't we? But it's okay. The first thing I want you to do when you get a long string like this and you're asked to combine like terms is first identify your like terms. Find out which terms are like to see if you can even combine any. I'm going to begin with 5x to the third power. Are there any other x to the third powers here? And yes, there are. I want you to notice that I not only circled the term, I circled the sign in front of it because the sign in front of the term belongs to the term. Okay? How about my y's? I have a 3y and then I have a minus 2y. So these are like terms. I'm going to go ahead and box those in. And then minus 4x squared. Well, do I need any 4x squared anywhere? Do I have any other ones? I don't. So it's going to just be minus 4x squared in my simplified expression. So make sure you leave that minus with it. Now remember I told you you would use the commutative property of addition. Let me show you why this works, because you're saying, well, this is subtraction. Miss Kimball, subtraction's not commutative. And you're right. But remember that we can change subtraction to adding the opposite. So if I keep that in my mind and I say, well, this is really the same concept as adding a negative 2y, and then I can move them around as long as I keep that minus in front of it. So I'm just going to rewrite this in an order. The second thing I said is rearrange. So if you want to rearrange the terms so it makes sense to combine them, we're going to go ahead and do that. So I have 5x to the third plus 7x to the third plus 3y minus 2y. If you're more comfortable writing, plus a negative 2y, be my guest. And then I'm just going to have to squeeze it in here, minus 4x squared. Now the last step, once you have it rearranged, making sure the signs are staying with the terms, you go ahead and simplify, combine the like terms. And we do that by adding or subtracting the coefficients based on the sign. Excuse me, so 5x to the third plus 7x to the third is 12x to the third plus 3y minus 2y. 3y minus 2y is 1y. It's a positive 1y. So I can say plus 1y minus 4x squared. Now what if my solution here would have been negative? If it would have been a negative solution, then I would put minus that number or plus the negative number. Okay, and we'll talk about that more. Is there any way I can simplify this any further? You don't have to, but you can rewrite it as 12x to the third power plus y minus 4x squared, because remember 1y is equivalent to just y. You just have one of them, you can just use the variable. And example C, I have 45x minus 37y plus 87. So I'm going to go ahead and find my like terms. 45x, x's, y's. Do I have any like terms here? I do not. So this is my answer. If you were being tested on this, you could just say, cannot combine, or you could just recopy this as your answer. Either way, I know what you mean. Lastly, this is one of my favorite things. Write an expression for the perimeter of the triangle, and then combine like terms in the expression. Well, if you're finding perimeter of something, what you're doing is you're adding up all of the sides. Okay? So in this case, I'm finding the perimeter of the triangle. I want to add this side plus this side plus this side. And I don't know specific numbers for them, but I do know that they're represented by expressions, algebraic expressions. So if I'm asked to find the perimeter, I know how to combine terms and expressions now, so that's what I'm going to try to do. I'm going to say, well, x plus, because remember in perimeter you add all the sides together, 2x plus 3, which is here, and I can check them off as I use them, plus 3x plus 2. Now I don't have to think about this anymore. If this scared you to death, now you're just working with this. A simple algebraic expression where you're asked to combine like terms in the expression. Well, do I have like terms? I have an x, a 2x, and a 3x. Well, x plus 2x, remember there's that 1 there. 1x plus 2x is 3x, plus 3x is 6x. And then I have my constants, 3 plus 2. It's going to be 6x plus 5. And that is the perimeter represented as an algebraic expression. Does this have to be written this way? It doesn't. What if you said 5 plus 6x? Is that correct? Of course it is. Why? Addition is commutative.